Next, we're going to go to the actual configuration of AA on the ASA. We're going to follow the same setup. We're going to do integration with the DAC server, with the fallback on local database, and perform likewise with authentication, authorization, and accounting as well. Now, from the ASA point of view, configuration will be similar to what we've done on the iOS. Couple of differences which are going to make sense just because ASA is a different platform. So first of all, we don't have to enable a new model or something on the ASA. Like the ASA by default uses the new model. We just have to start by configuring integration with the DAC server. Then if you want to provide local fallback in case DAC server is not available, likewise you got to configure in the local database of the ASA couple of local usernames and passwords. Then we have to configure likewise the authentication, authorization, and accounting just like on the iOS. The same thing, authentication, authorization via TagX Plus and local fallback optionally, and also accounting only via TagX Plus. Now, as you're going to see, ASA for security reason does not allow direct access to privileged mode. So enable authentication is required. So what I saw in the iOS is that when we have configured the TagX server for exec authorization to actually return a privilege level of 15 and it worked, on the ASA that's not going to work for security reasons. So what I saw before on the iOS was that, so we had router 3, router 2, and the TagX server, where 3 was the supplicant, 2 was the authenticator, and ACS was the authentication server. So what happened is that when we configured on the supplicant both the authentication list and exec authorization, which means shell access and privilege level exec authorization, and also on the ACS server we have also configured privilege authorization, privilege level authorization. Then what happened is that when router 3 has telnetted or SSH to router 2, has given the username and password, and router 2 has relayed those credentials over to TagX server for authentication. Because it has matched the access policy rule on the ACS server, which had included the privilege level authorization. If authentication was successful, then when the ACS server replied over to router 2, it also sent router 2 assign a privilege level of 15 or whatever you have configured to this session. So just by getting authenticated, router 3 got access to privilege mode. But on the ASA, if we replace router 2, if we would replace router 2, which is the authenticator, with an ASA, for security reasons, even though ACS server may return as part of the authentication process that privilege level, the ASA is going to ignore it. That's for security reasons. So on the ASA, if you want to get privilege level 15 access, once you got authenticated, and of course I did something wrong in here. Clearly the authentication and authorization lists have been applied on the authenticator, right? Not on the supplicant. So in here on this side, on router 2, we had authentication and exec authorization configured. So now if we do the same thing on the ASA, as I stated, if we replace router 2 with an ASA, then once the user gets authenticated, it's going to always be, let's say, given a privilege level of 1. So if we want actually that router 3, when it telnets over to the ASA or SSH to the ASA, to get level 15 access, we have to make use of the enable authentication. So the supplicant has to also say to the SA, enable 15, so get me access to privilege level mode. And then the ASA is going to send over to the ACS server a request saying for that user requests a privilege level of 15. Do you allow that? And if ACS is likewise configured with authorization policy, ACS is gonna say yes and put a user into privilege level mode. So for security reasons, the ASA, if you want to get access to privileged mode, which means be able to configure the ASA, you have to authenticate first via the login authentication list, get access to your user mode, and then you have to perform enable authentication to get access to privilege mode. So because it's a security device, it has added features to be more secure, to call it that way. And of course, ideally on the ACS server, for security reasons, when you define a user of X, let's say on the ACS server you define a user of X, user of, let's say, XYZ, you're going to have the login password to be ABC, for example, and the enable password to be something else, for example, WAB, because this adds more security. Because if somebody knows the username and the password, they still have to know also the enable password of the user. And by default, when you configure a username in the database of the ACS server, the enable password is going to be the same as the login password. So ideally you should have those two to have a different value. So the login password and the enable password should be different. This has nothing to do with the ASA. It's like in general, a general recommendation. What this means is that if you make use of the enable capability to get access to privilege mode, ideally on the ACS server you define the users with a different enable password as opposed to the login password for added security. Now on the ACS side, it's going to be pretty much the same thing. So just configure integration with a NAD. This time the network access device being the ASA. Likewise, configure local username and password. Configure authorization profiles attributes, which means privilege level assignment and command authorization list. And also configure the authorization list in there, or the access policy, and bind the authorization profile to that authorization list. So this time we're going to go on the ASA and first perform, like we did on the iOS, first do the authentication part, confirm that works, then do the authorization part, confirm that works, then do the accounting part, confirm that works. And we're going to, let's say, SSH from router 3 to ASA. So 3 is going to be the supplicant, ASA the authenticator, and TACAC server the authentication server. So before we get going, let's make sure that ASA 3 allows SSH traffic from router 3. So SSH has to be enabled, and SSH traffic from router 3 is being allowed. So we say show SSH. It is configured version 2 allowed, and traffic from router 2 is allowed, not from router 3. So let's say SSH from relative, which is 136.138.3 on that interface. On the interface of gig01 of the ASA, which means likewise the outside interface. So SSH is enabled. Allowed from .3. Next, let's move on. Let's try and do the configuration from the CLI, and then we're going to look at the from ASDM. Login. Let's say refresh to review the config. And then this should be under configuration, and not a firewall should be. And there we go. We have in here the AA rules. In here we're going to add pretty much the authentication, authorization, and accounting rules. But of course, before that, we have to configure the integration with the TACAC server, which should be ideally under device management. Let's see if that's the case. And the users AA, there we go. So first of all, let's define a local user account. Just for this purpose, user account, I'm going to say add. So for the local fallback on the local database of users, add. Let's say ASA user with a password of ASA user and ASA user. Now on the ASA, because usually we define users on the ASA also to get VPN access, if you don't integrate the ASA with other remote servers for authenticating VPN sessions, it's dangerous to define users in the local database because those users may actually connect to the ASA to manage it. So for that reason, the ASA has a set of built-in security, which when you define a user, you can tell, okay, for that user can get what kind of access on the device. Full access, which means it can manage the ASA completely. CLI, so no SDM access. Or only no SDM, no SSH, no management capabilities on the ASA, which means only it can be used only for VPN. Now, of course, it's another long discussion to make sure that those if you use option A or option B or option C, to make sure those are enforced, it requires also, it depends on the A configuration, it may require other configuration. But for our use case, we want to give that user full access. Clearly, we want to give that user full access, which let's assign that user a level of 15 to begin with. Level of 15. So define a local username with a privilege level of 15 on the ASA, which has full access to manage the ASA based on our configuration. Let's say OK. And say apply. Then we go to AA server groups, and we configure the integration with the AA server. We go under server groups, and we say add. As you can see, so on the ASA, there is no need to enable a new model, because by default ASA has the a new model, because it has the local, it has authentication. It can be achieved initially only via the local database of users. Let's say add. A server group, give it a name. Let's say TACAC servers, likewise. Protocol to be TACAC plus. And pretty much that's everything which we define in here. We just define the server group and a protocol. Okay. We say apply. Let's make sure I probably configured it. Just a name, and there we go. And then we go in here and say add. So we click we click on the server group, and we go in the portion of servers that are in the server group, and we click add to tell the ASA what are the servers in that server group. We click add in here, and interface name, the ACA server is reachable via the ACS interface of the ASA name if wise. The IP address of the attacker server is going to be 172.16.1.100. Server port is clearly 49 by default. You cannot change that because the ACS cannot run on another port. And the key to authenticate, to provide security of the TAGAX packets between the server and the, so the key we defined in here, which was the same key, which was the same functionality as we did on the integration between the iOS and the TAGAX server. That key value is used to both authenticate the NAT to the TAGAX server and also to provide security for the TAGAX packets in the end. Let's say ASA TAGAX. Let me type in slow ASA TAGAX to make sure there's no typo. Okay? And we say apply. So currently if you look at the ASA, we just define the username, ASA user for local fallback. We have defined a group of servers for protocol TAGAX, and then we have defined out of that group of servers what are the actual servers which are in the group of servers, which is the ACS, what a key of ASA TAGAX. As you know, if you want for security reasons, the key is not displayed in show run. If you want to see it, you gotta say more system run and config include key, and the key was ASA TAGAX. Then we have to configure, let's say, the authentication list, but on the ASA you configure the authentication list not like globally like you did on the iOS. Like you define the list globally and then you apply it at the VTI lines, and then that list is gonna be active for all incoming connections on a VTI lines or on the console or on HTTP. What you do on the ASA instead, you define, let's say, authentication list per type of incoming connections. Like how will the ASA be managed? Via SSH is going to be configuration of SSH, via telnet configuration, via ASDM configuration. So ASDM wise, we go now to configuration firewall. Under AA rules, we say add authentication rule. Actually, this is for something else. This is for another firewall feature. Let's go back to device management. Should be still in there. And then we go to, I think it's under AA access. It makes sense because under firewall, you're gonna define something which has to do with the firewall allowing access back and forward. So you should still be under device management because this has to do with the management of the device. And probably it's under AA access. And there we go. So we define the authentication for which protocol? For enable, for HTTP SDM, for console, that's the civil, for SSH, for telnet, for what we want to enable authentication. I'm not going to change SDM because I want to, of course, I want to leave SDM to use local authentication. So initially I'm going to choose to provide SSH authentication via the group of servers or a fallback on the local database. So I'm telling the ASA to authenticate all SSH sessions against that TAGAX group of servers, and if there is no connectivity with that group of servers, then fallback on the local database. So the difference between ASA and iOS is that on iOS you define a list, And if you use a default list, you don't have to apply this. By default, apply to all incoming methods to the router for management, console, VTI, HTTP. If you use a name list, you have to apply it to where do you want to enforce that authentication list. While on the ASA is different. On the ASA, you just configure an authentication method per type of incoming connections. For SSH, for Telnet, for HTTP, SDM, for whatever, for enable and so on. So initially I just want authentication for SSH, like that, say apply. And send. If you go now back and say show run AA, gonna see exactly that for SSH. I'm saying all incoming SSH sessions, assuming they are allowed, which means assuming the ASA runs the SSH service and that source is allowed to connect to the ASA. So if I allow the SSH session, then I'm going to authenticate that SSH session against that group of servers, which you know it's a TACAC server. And if I don't have connectivity with that server, then I'm going to fall back on the local database. So pretty much we're done on the ASA. For the authentication part, we got to go on the ACA server and follow up on those steps. Let's refresh because probably the session timed out. So first step was to provide integration with the network access device. So go under network resources, and we have to add the ASA as a NAT client. And the ASA doesn't have the concept of a loopback, doesn't support loopbacks. So the ASA is going to route the packets. You're going to initiate TACAX packets with the source of its gig00992 interface, which has an IP address of 172.16.1.1 in that subnet. So we say network devices and AA clients, and we say create ASA tree with an IP address of 172.16.1.1 and no radius configuration. We do just TACAX integration, and the secret key is going to be ASA TACAX. And we say submit. We're going to make use of the same username of TACAX user. I'm not going to add a new username. So that step has been done. I want to make use of the same username in there. But as I stated, I'm going to edit that user. Cancel, not edit, but change password. I'm going to click the user and say change password. And as I stated, so the user is TACAX user, and the password was TACAX user as well. This is the login password. The enabled password, if you're not configured, is going to have the same value as the login password. So let's go and change the enabled password to be TACAX enabled, for example. And let's say OK, submit. So define a user. Then the last step is to go and let's temporarily disable that access policy because I just want to get access. So we're going to say access policies, and then we say default device admin authorization, and let's temporarily say edit and disable this rule because initially I just want to get authenticated, just like on the I did with the iOS router, save changes. Which means I'm going to match on the default. Let me remove that, okay. Versus the reason, save, okay, I'm okay. Save changes. Which means I'm going to match on the default rule, which states just allow access. Permit access, of course, as long as the credentials provided are valid. So now if we go on in here, and now we tell it we SSH to ASA3, ASA3 should authenticate as SSH session against ACS1. So let's confirm that, and I should get access to privilege level 1. So from router3, we say SSH -L TACACS user to ASA3 136.1.38.1 TACACS user. So I got connected and expect I'm a privilege level of 1. Show priv. Show current priv, the command is different. I'm a level of 1. And username is TACACS user. Now let's configure the exec authorization part. So let's go in the SDM. And now I go under the authorization tab in here. I go under the authorization tab. Authorization. And I don't want initially authorization for like enable. I want for exec shell access. I'm going to say enable. Say send. If we go on the ASA, we say we have show run on the SA. We have show run include AAA. This command showed up. Authorization exit from the authentication server auto enable. Now if we go on the ACS server now, and we re-enable that rule, we say edit, which means that now if the user is in the old groups, which means it is going to be the TACACS user, then provide authorization as the shell profile states, which means allow privilege level 15. So let's re-enable this rule now. So let's say edit and re-enable it. Disable, put it back to enabled. Okay. And say save changes. So now if we go to router 3 and SSH again, TACACS user, I got access to 50. If you say show current priv, I got access to 15, which this is something which me personally, I was not aware, so it's a new feature they added because this keyword in here was not available in the older platforms. So I'm not sure when they added this capability in here. Because if we just say authentication server as it used to be before, show run include AA, This was supported in the older codes. And if we SSH, if we exit and SSH again, and we say tacax user, didn't even work because that command was doing something else. So this is a new capability they added. So I'm going to change also those slides. So if you do this, then you're going to automatically get assigned to the level as configured on the ASA server. But there is a problem with this command, which it's something that you gain and you lose. If you look at the command, it says AA authorization exec. You're going to authorize exec access for incoming users to manage the ASA, as the authentication server tells you, which is going to be a remote authentication server. Because if you look in the GUI in here on the ASA, so when you enable exec shell authorization, you enable it. You can either use authorization from the remote server or from the local database. There is no fallback in between. So there is a new feature which basically allows the ASA to behave just like the iOS. So if the ACA server, if the attacker server was configured to assign a level of 15, then when the user connects, it's going to get the level of 15 directly. But the problem is there is no fallback to be configured, which means that if the remote server fails, you're not going to be able to get exec access in there. So ideally, you should not use this in here. Ideally, what you should do, because you want to provide fallback, you should configure authorization exec access by using the enable capability in there.